Welcome students to online classes of mathematics for class 9th. In this video we are going to study chapter number 9, which is areas of parallelograms and the triangles of NCERT textbook. And this one is the session number 3 for this particular chapter. We will be looking at the exercise 9.3 and we will do the first 3 questions of exercise 9.3. That's why I have written it as part 1. Okay. Myself Deepak Kodam, TGT Mathematics in Kendriya Vidyalaya Sangathan. So let's start with our today's class. In chapter number 9, areas of parallelogram and triangles is divided into total 3 subtopics, out of which we have already covered the first 2 subtopics in the previous session. Now in this session we will be looking at the third subtopic, which is triangles on the same base and between the same parallel. Okay, so let's start. The topic triangles on the same base and between the same parallel. In this we have the theorem 9.2, which says the statement of theorem is two triangles on the same base, or you can say equal base. Okay, earlier we had the one condition only where the bases has to be same, but in case of triangle we can also have equal bases. Okay, and between the same parallel are equal in area. Okay, so what this theorem is saying is, when we have two triangles which are either on the same base or on the equal base, but they has to be lying between the same parallel line, then the area of the two triangle will be equal. Okay, so let's look at the proof of this theorem. First we are going to write the given here is, we have taken a parallelogram ABCD in which AC is one of its diagonal. Okay, so let's write given is a parallelogram ABCD in which AC is one of its diagonal. Okay, we are given with a parallelogram ABCD in which AC is one of its diagonal. Okay, and we have to prove here that the area of the two triangle is equal. Okay, the area of the triangle, which are the triangles, are triangle ADC and triangle ABC. Okay, you have to prove that the area of triangle ABC is equals to area of triangle ADC. Okay, for this we are going to do a construction. Construction is, we will draw an altitude, or you can say height, of this triangle or a parallelogram, which is AN perpendicular on DC. Okay, so construction is draw AN perpendicular to DC. Okay, now let's start its proof. As we know, if we draw a diagonal in a parallelogram, that diagonal will divide the parallelogram into two congruent triangles. Okay, so we'll write, since AC is the diagonal of parallelogram ABCD, since AC is a diagonal of parallelogram ABCD, therefore the area of the triangle, so the triangle ABC will be congruent to triangle ADC, as we know that a diagonal of a parallelogram divides into two congruent triangles, and we already know that if two figures are congruent, then their areas will be equal. Okay, or we can write, hence if these two triangles are congruent, then the area has to be equal. That is, area of triangle ABC will be equals to the area of triangle ADC, and this is what we are asked to prove here. So we have proved that the two triangle ABC and ADC are equal in area. Okay, so we are here having the case of when the bases are equal. Okay, so these two triangles, which is ADC and ABC, they are lying between the same parallel, which are AB and DC, but they are not on the same base, but they are on the equal base. As we know, the opposite sides of the parallelogram are equal. Okay, so ABC and ADC are the two triangles which are on equal base and between the same parallel, and we have proved them that their areas are equal. Okay, so from here we can conclude one thing, that the area of the triangle, we can write, therefore area of triangle ADC can be written as this triangle ADC area, its area can be written as base into height. Okay, its height is AN and base is DC. Okay, so we know that the area of a triangle is given as half into base into altitude. Okay, for triangle ADC we have half, base here is DC and altitude is here is AN. Okay, and since we know that the opposite side of a parallelogram are equal, so this DC will be equals to AB, so we can write this as, or this as half into, it's in place of DC we can write AB into AN, as we know that DC is equals to AB because they are the opposite sides of a parallelogram, they has to be equal. Now this half into base into height. Okay, now the base is AB and the height is will for this triangle will be again AN. Okay, so we can write this as equals to the area of triangle ABC. Okay, so here again that is the area of triangle ADC is equals to area of triangle ABC. Okay, so we have again come to the conclusion that the area of the two triangle is equal. Okay, so from here we can conclude that the area of any triangle can be given as, that is area of triangle is given as half into base into altitude. Okay, this is something you've already studied in the previous class. This was introduced to you in class 7. Okay, we are just using that here, that the area of the triangle is given as half into base into height. Using that we have again proved that the area of the two triangle is equal. Okay, so I hope you understood the proof of the theorem 9.2. It simply says if you have two triangles which are on the same base and between the same parallel, or if the bases are not same but base can be equal, in that case also if they are lying between the same parallel, the area of the two triangle will be equal. Okay, next we have the converse of this theorem 9.2, which says, which is theorem 9.3. It says the two triangles having the same base or equal base and equal area lie between the same parallel. Okay, so if we have two triangles which have equal base or the same base and lying between and having equal area, then they must be lying between the same parallel. Okay, this is the converse of theorem 9.2. In 9.2 we have same base and between same parallel, then the area of the two triangle is equal, while in the theorem 9.3 we have same base or equal base and we are having equal area, then this will conclude that the triangles must be lying between the same parallel. Okay, so theorem 9.2, these two conditions given that they are having same or equal base and between the same parallel, then the area of the two triangle is equal, while in 9.3 they have same or equal base, equal area, then they must be lying between the same parallel line. Okay, so that's the theorem 9.2 and 9.3. Okay, now let's look at one important topic before moving to the one example of this before the exercise 9.3. so first you have to recall what you have already studied, that is the median of a triangle. Okay, so simply a median of a triangle is, suppose we have this triangle ABC. Okay, we are joining the vertex A to the midpoint of its opposite side. So this opposite side is BC and the midpoint of opposite side BC is D. So if we join A to D, we will get a line segment which will be called the median of the triangle. Okay, so simply median of a triangle is a line segment joining a vertex to the midpoint of its opposite side, thus bisecting that side. Okay, so what simply a median is, it is a line segment which join the vertex of a triangle to the midpoint of its opposite side. Okay, suppose we have this triangle and we are drawing median from this point, let's name it A. Okay, from this point we'll mark the midpoint of its opposite side, which is will be here. If we join these 2 points, so this line segment will be called the median. Okay, that's why I have it drawn here. Okay, so we have triangle ABC in which D is the midpoint of side BC. If we join vertex A to D, you will get a median. Okay, So every triangle has exactly 3 median, because a triangle has 3 vertices, so from each vertex we can draw a median. Okay, so every triangle has exactly 3 median, one from the each vertex, and they all intersect each other at a point, and that point is called centroid. Okay, you can see in this figure we have triangle ABC. From the each vertex, that is from A to its opposite side BC, we are marking a line segment. Again from vertex B to its opposite side AC, we are drawing a line segment, and we are doing the same with the vertex C. Okay, joining it to the midpoint of side AB. So when you draw all 3 median, they will certainly intersect each other at a point between the triangle, okay, in the interior of the triangle, and that point is called the centroid of the triangle. Okay, so a triangle has 3 medians, one from each vertex, and they all intersect each other at a point, and that point is called the centroid of the circle. Okay, I hope you understood. Median is the line segment joining a vertex of a triangle to the midpoint of its opposite side, and when you draw the all 3 median for a triangle, the medians will intersect at a point, and that point is called the centroid of the triangle. Okay, now based on this we have a very important example which is given in your book. It's on page 161 in your NCERT textbook. Okay, this is a very important example. Okay, so question is, show that a median of a triangle divides it into 2 triangles. We have to show that the median of a triangle divides into 2 triangles of equal area. Okay, that means if we have a triangle, let's say this one, and we are drawing its one median, and we have to prove that the 2 angles formed by this median are equal in area. We have to prove that the area of this triangle is equals to this triangle. Okay, that's what we have to prove here. Okay, so let's start. First we'll write the given here is a triangle, say ABC, a triangle say ABC, as the name of the triangle is not given in the statement, so we are taking it as ABC. That's why I have written here say. Okay, say ABC in which AD is one of its median. Okay, as a triangle can have 3 medians. Okay, so we have drawn only one median, which is AD. So given is a triangle say ABC in which AD is one of its median. Okay, what we have to prove here is, we need to prove here is that the 2 triangles formed by this median are equal in area. Okay, we have to prove that the area of triangle ADB is equals to the area of triangle ABC. Okay, that's what we have to prove here, that the 2 triangles formed by this median are equal in area. Okay, we'll start with the construction. So construction is, we will draw an altitude, or you can say perpendicular, AN, which is falling on the side BC. Okay, so construction is draw AN perpendicular on BC. Okay, now let's start its proof. Proof here is, what we are going to do is, we'll take both the triangle and we'll find their area by using formula half into base into altitude. Okay, so we'll write in triangle ADB we have the area of triangle ABD will be given by base half into base into altitude. Okay, in this case we have this half. Base for this triangle ABD is this BD. Okay, so at the place of base we write BD, and the altitude is AN. Okay, and we can write that this replace this BD by DC, because we know that D is the mid, as AD is the median, So D will be the midpoint of the side BC. Okay, so write as AD is a median of triangle ABC, therefore the BD has to be equals to DC. Okay, because D will be the midpoint of the side BC, only then it can be a median. Okay, so what we got is BD equals to DC. So in this equation, let's name it equation number 1 in this equation and name it equation number 2. Okay, we can use the equation 2 in equation 1. We'll get that right using equation 2 in equation 1. We get what we get here is that we'll replace this BD by DC. Okay, so this will be area of triangle ADB will be equals to half into DC into AN, and this half into DC into AN will give us area of triangle ADC. Okay, now that's what we are asked to prove, that the area of triangle ADB is equals to the area of triangle ADC. Okay, solution of the example number 2. So from here we conclude that if we draw a median in any triangle, that median will divide the triangle into two triangles and the area of those two triangles will be equal. Okay, as this median AD is dividing the triangle into two triangles. Okay, this AD is dividing triangle into two triangles and the area of this both triangle are equal. Okay, as we have proved here. So we are going to use this theorem 9.2 and the 9.3 and the statement of the example number 3 in the next exercise, which is 9.3. okay, so now let's start the exercise 9.3. we will be looking at the first 3 questions only in this particular session. Okay, so this is chapter number 9, areas of parallelograms and triangles, exercise 9.3. Here the question number 1 is, in figure 9.23, E is any midpoint on median AD of triangle ABC. Show that the area of triangle ABE and ACE are equal. Okay, what we have to prove here is that the area of triangle ABE is equals to area of triangle ACE. Okay, we have to prove the area of these two triangles equal. So let's start the answer number 1. First, we'll start by writing the given part. Given here is a triangle ABC, a triangle ABC in which AD is one of its median and E is a point on it. Okay, so what we have is a triangle ABC in which AD is one of its median and E is a point on it. On it means if the E point is on median. Okay, what we have to prove here is, let's try the to prove. We have to prove that the area of triangle ABE is equals to area of triangle ACE. That area of triangle ABE is equals to area of triangle ACE. This is what we have to prove. Okay, so now let's start this proof. So what we are going to do is, we are going to use the statement of example number 3, which says the median of a triangle divides it into two triangles of equal area. Okay, so we'll write in triangle ABC, AD is a median. Therefore the area of triangle ADB will be equals to area of triangle ADC. Okay, this is by the statement of example number 3, which says, you have to write the statement here, which says the median of a triangle divides it into two triangle of equal area. Okay, median of a triangle divides into two triangle of equal area. So we got the two triangle ABD and ADB and ADC, which are equal in area. Let's name it equation number 1. Okay, now we'll come to the triangle EBC. For this triangle, this ED is again a median. Okay, so we'll write, and in triangle EBC, ED is a median. Therefore the area of triangle this one triangle EDB and the second triangle is EDC, EDB will be equals to the area of triangle EDC. Let's name it equation number 2, and the reason for this one is again the statement of the example number 3. Okay, again you have to write the statement, that is the median of a triangle divided into two triangle of equal area. So we got two equations. Now what we're going to do is we'll subtract the equation 2 from equation 1. Okay, so we'll write on subtracting equation 2 from equation 1, we get, what we get here is, earlier we calculated the area for this entire triangle. Okay, and now we are going to subtract the area of this triangle. So what we left it is with the area of only red triangle. Okay, so we'll write area of triangle ADB minus area of triangle ADB. On the other side we have area of triangle ADC, and we are subtracting the area of triangle ADC. So after subtraction, after subtracting this triangle from this complete triangle ABD, you will get area of triangle ABE. Okay, so here we'll get area of triangle ABE, and that will be equals to the, when you subtract this EDC from ADC, will get the area of triangle ACE, and this is what we are asked to prove. Okay, so that's the solution of question number 2 of exercise question number 1 of exercise 9.3. Okay, now moving to the next question, which is question number 2. It says, in a triangle ABC, E is the midpoint of median AD. Show that triangle BED, area of triangle BED is equals to 1/4 the area of triangle ABC. Okay, so what we have here is, we have a triangle ABC. Let's say this one ABC. Okay, I'm drawing a roughly figure, and E is the midpoint of median AD. So let's draw a median, which is ED, and now we have midpoint of this median, which is E, and we have to show that the area of BED, when you join this BED, that the area of this triangle is 1/4 the area of this complete triangle ABC. Okay, so let's first draw its figure. So that's the figure for this question. We have triangle ABC in which AD is one of the median and E is the midpoint of the median AD. Okay, we have to prove that the area of this triangle, which is BED, is equals to the area of the complete 1/4 the area of the complete triangle ABC. Okay, so let's start writing the answer number 2. We'll start with the writing the given part. Given here is a triangle ABC, a triangle ABC in which E is the midpoint of median AD. Okay, E is the midpoint of the median ED, and we have to show that the area of BD is equals to 1/4 the area of ABC. Okay, to prove here is that the area of BED is equals to 1/4 the area of ABC. Okay, so let's start the proof now. Again, we are going to start with the using the statement of example 3, that the median of a triangle divided into two triangles of equal area. Okay, so we'll write in triangle ABC, AD is a median. Okay, in triangle ABC, AD is a median. Therefore the area of triangle ADB will be equals to the area of triangle ADC. Okay, this is again by this statement of the example 3. You will write that here, that the median of a triangle divided into two triangles of equal area. Okay, since the area of these two triangles is equal, that is the area of triangle ABD and area of triangle ADC are equal, as written here. We can write this as, or the area of triangle ADB can be written as half the area of the complete triangle, that is half the area of triangle ABC. Since the both area of the both part is equal, so the one can be written as the half of the whole. Okay, that is half of the complete triangle ABC. Okay, now let's name it equation number 1. Now we are going to concentrate on the second triangle, which is this one, triangle ABD. In this triangle, since E is the midpoint of AD and this BE will be the median for the triangle ABD. Okay, so we'll write, and in triangle ADB, BE is a median. Therefore we can write this as the area of these two triangles will be equal. Okay, that is the area of triangle ABE will be equals to BED. Area of triangle BED will be equals to the area of triangle ABE. Okay, area of triangle BED will be equals to area of triangle, we can say BEA, or we can write this as BEA. Okay, this BED will be equals to the area of BEA. This is by the example number 3 again, that is the median of a triangle divided into two triangles of equal area. Again, we can write the area of triangle BED as the half of the whole triangle, that is area of BED can be written as half of the whole triangle, which is triangle ADB, because these two are the part of the triangle ABD. So the one part, if the area of the both the triangle is equal, so then the one part can be written as the half of the area of the complete triangle. Okay, now let's name it equation number 2. So now on using the equation 1 in equation 2, that is we have this area of ADB is equals to half the area of ABC. So we can replace only this part in equation 2 by the value half into area of ABC. Okay, so we'll write, on using equation 1 in equation 2, we get, what we get is, we'll keep the equation 2 first as it is, that is area of triangle BED. Okay, we have half into area of ABD, and here we have calculated the area of ABD, which is half the area of ABC. Okay, so at the place of this part we'll write half the area of triangle ABC. Okay, and when we open this bracket, we'll get area of BED will be equals to this 1 by 2 into 1 by 2 will become 1 by 4 area of triangle ABC. Okay, and that's what we are asked to prove here, that the area of the triangle BED is 1/4 the area of triangle ABC. Okay, that's what we have proved here. Okay, so that's the answer of question number 2. Now let's move to the question number 3 of exercise 9.3. Question is, Show that the diagonal of a parallelogram divides it into four triangles of equal area. Okay, we are going to show that the diagonal of a parallelogram divides it into two triangles of equal area. So we have a parallelogram. Let's draw a rough figure. And in this parallelogram we have two diagonals. This, let's name it A, B, C and D, and the point where the two diagonals intersect as O. So we are going to prove that the area of this all four triangle is equal. Okay, so let's first draw its figure. So that's the figure for this question. We have parallelogram ABCD in which AC and BD are two diagonal, and what we have done here is we have done a construction which is we have drawn this PL perpendicular on AC. Okay, so let's write the answer number 3. First we'll write the given. Given is a parallelogram ABCD, a parallelogram ABCD in which AC and BD are its two diagonals intersecting at point O. Okay, so what we have to prove here is we have to prove that the area of the all four triangle is equal. That is, we have to prove that area of triangle AOB is equals to area of triangle BOC is equals to area of triangle COD is equals to area of triangle DOA. Okay, so that the area of the all four triangle is equal. Okay, that's what we have to prove. We're going to start with the construction. Construction is draw BL perpendicular on AC. Okay, draw BL perpendicular on AC. Okay, so now let's start this proof. So we are going to first start with the triangle AOB and BOC. Okay, so we'll write, since ABCD is a parallelogram, since ABCD is a parallelogram and AC and BD are the two diagonals intersecting at O. Okay, and the diagonals AC and BD are intersecting at O. Okay, so what we get here is, and we know that the diagonals of a parallelogram bisect each other, so therefore this AO will be equals to OC and BO will be equals to OD, because diagonals of a parallelogram bisect each other. Okay, reason for this one is diagonals of parallelogram bisect each other. Okay, so we got OA is equals to OC and BO is equals to OD. Okay, now let's see. Now in triangle AOB, what we have is the area of triangle AOB will be equals to, as we know, half into base into altitude. That is, half base for this triangle AOB will be AO. Base for this one is AO and altitude will be BL. Okay, so as we know this AO is equals to OC, so we can replace this AO by OC. That is, at the place of A will write OC into BL. Okay, then this will become the area for the triangle AOC. Okay, so what we did here is, we know that since ABCD is a parallelogram, and we know that the diagonals of a parallelogram bisect each other. Okay, therefore the AO will be equals to OC and BO equals to OD. Okay, we have come to the triangle AOB. We have calculated the area of triangle AOB by the formula half into base into altitude. So base for this triangle is this AO, and altitude is for this triangle is BL. Okay, so its area will be half into AO into BL. Since we have already done this, AO is equals to OC, so we can write at the place of AO we can write OC. Okay, write the reason here, since AO is equals to OC, that's why we can write this half into OC into BL, and this will give us the area for the triangle AOC. Okay, so what we got here is, that is area of triangle AOB is equals to area of triangle AOC. Okay, so what we got here is, from we have proved that the area of AOB is equals to BOC, not AOC. This will be changed to BOC. Okay, and this will be BOC. So what we have proved here is that area for triangle AOB is equals to BAC. So we have proved the first two part. Okay, now we'll prove that these two triangles are also equal, then we'll prove that these two triangles are equal, and eventually the last and the first two triangles are also equal in area. Okay, so instead of doing that again and again, we'll write similarly we can prove. Okay, similarly we can prove, because the method for proving this is exactly similar, so we're not going to show it again and again. We'll write similarly we can prove that the area of triangle BOC is equals to area of triangle COD, and area of triangle COD is equals to area of triangle DOA, and area of triangle DOA is equals to area of triangle BOC. Okay, let's name this equation as equation 1, equation 2, equation 3, and equation 4. Okay, so we'll write from equation 1, 2, 3, and 4 we get, from equation 1, 2, 3, and 4 we get that the area of triangle AOB is equals to area of triangle BOC is equals to area of triangle COD is equals to area of triangles DOA, and that's what we are asked to prove here. Okay, so what we did here is, we started with the two triangles, this one and this one. We have proved that the area of these two triangles is equal. Okay, similarly we can prove that the area of these two triangles equal, then the area of these triangles are equal, and in the end area of the remaining two triangles are also equal. So instead of showing that steps again we can write after proving one that similarly we can prove that the area of the other three cases also equal. Okay, let's name it equation 1, 2, 3, and 4. From equation 1, 2, 3, and 4 we get that area of the all four triangle is equal, and this is what we are asked to prove here. Okay, so we have completed the first three questions of exercise 9.3. okay, we'll be covering the remaining question in the upcoming session. Okay, so what you have to do is practice all this question multiple times so that you will understand them better. Okay, so that's all for now. Thanks for joining here everyone. Thank you.